So the impulse momentum theorem tells us that a force times the time that the force is applied, so the force times the time, which we call the impulse, that impulse causes the momentum to change, the momentum of a system. So we're going to solve an example problem of how you apply this, and then you're going to solve some of your problem set today. So a quick note, I'm going to ask that you follow this as you solve your problems and you make your solution plan. When we are talking about our solution plan and our solutions, we apply a theorem. So if your problem starts with a theorem, like the conservation of energy, so that's like, ME final equals ME initial plus W, that's a theorem, that's a big idea, principle. Or Newton's law, for example, the net force equals the mass times acceleration, or the impulse momentum theorem, which is up here. When we apply it to a problem, we say we're going to apply a theorem, okay? Now, if you have an actual equation with the variable you're looking for in it, we say we solve the equation. So once we write this out, we might have an m in it. So we can then say we're going to solve that equation for m. You cannot solve this theorem or this principle for m because there's no m explicitly stated in it. So if you have an equation and you're rearranging it for a variable that's in the equation, we say we solve the equation. And if we have an expression that we're evaluating, then we say evaluate. So this is if you're not solving. So for example, if you have V final equals V initial plus A times T, and you're just trying to find V final. You're not really solving for V final. It's already solved. You're evaluating this expression to find V final. Okay? So I'll show you how that works down here. So here's an example problem. We've got a basketball player and he's going to hit the wall. So we've got a wall here. We've got a basketball player, and before the collision, he is running this way. He smacks into the wall, and then after the collision, he bounces back. So this guy's kind of a little bit rubbery. He kind of falls off. And this is a padded wall because you definitely don't want to hit the concrete behind a basketball goal when you're running and you get tripped or you lose your balance. Okay? So the variables that are involved in these problems are force, the time the force acts, we usually have the mass, we have the final velocity after the collision, and we have the initial velocity before the collision. So as we read the problem, he's initially going 6.25 meters per second. So in my diagram, I have that to the right. So my initial velocity is 6.25. And I always put units with my numbers. He is 75 kilogram body, so we know that's the mass. 75.0 kilograms is the mass. And it bounces off this wall, this padded wall, and it rebounds at 2.4 meters per second in the opposite direction. So if I have him moving to the right here, the rebound is to the left. So that tells me my final velocity is negative 2.40 meters per second. The question says, find the average force acting on him if the collision lasts 0.160 seconds. Okay, so that's our variable list. We are going to apply our principle, so that I start my plan by saying that I'm going to apply this principle. F times T equals delta P. Okay, when I apply it to this problem, I get the following expression. And this is what I want you to do. I want you to apply the principle to get an expression. That means that the force times the time equals the change in momentum, which is mv final minus mv initial. Okay? That is an equation. We can now solve this equation for F. All right? So I want you to tell me that you're applying a principle. Show me the equation you get when you apply the principle to this problem, and then tell me what you're solving for. And then, of course, solve it algebraically. So the force will equal, I'm going to factor out the m, so this is going to be V final minus V initial, all over T is my algebraic solution. And then I can plug in my numbers, plug in my numbers, and I will get 75.0 kilograms. The final velocity is negative 2.40 meters per second minus the initial velocity, which is 6.25 meters per second. all of that is divided by the time, which is 0.160 seconds. Plug that all in my calculator to evaluate it. And when I do that, you can see I get about negative 4,050 newtons. It's negative because the force was applied to the left. You can see the wall's got to push on the dude to the left in order to change the momentum. And I can have three significant figures. So this is going to be negative 4,050 newtons when I consider significant figures. So there we go. That's the average force acting on the basketball player as they smack into the padded wall and bounce back. Okay. Now, sometimes we will just ask for the magnitude of the force. The magnitude of the force just means how big is the force. And in that case, you're just taking the absolute value. You're just asking how big is the force, not what direction it's going in. So in that case, I would just report the answer without a sign. Okay? All right, so you're going to solve a bunch of problems applying the impulse momentum theorem. And you're going to upload pictures of your solutions. And so just so we're clear, you have to tell me the principle that you're applying, the equation you get as a result, and then tell me what you're solving for. Don't tell me you're solving for it down here after you've already solved it, and don't tell me up here that you're solving for f because you haven't applied the principle yet. So we apply a principle to get an equation, and then we solve the equation for whatever we're interested in. Okay? All right, good luck.